In science we do best. Miss C helps you pass the test. Whee!
Welcome to the How-To series of science videos with me, Ms. C. In these videos, we will tackle the topics which, at the moment, make your brain hurt and make them less painful. In this video, we're going to focus on how to calculate the relative atomic mass. Okay, so what is the relative atomic mass? The relative atomic mass of an element is the average mass of one atom of the element compared to 1/12 of the mass of one atom of carbon-12. If an element only has one isotope, its AR will be the same as its mass number. If an element has more than one isotope, its relative atomic mass, AR, will be an average of the mass numbers of all its different isotopes, accounting for how much there is of each isotope. Sometimes this value might not be a whole number. So that sounds a little bit complicated, but when we get into working out the relative atomic mass, you'll see that actually it's quite simple. So let's go and have a look at unpacking some vocabulary. What is an isotope? So isotopes are different forms of the same element, which have the same number of protons but a different number of neutrons. They have the same atomic number but different mass numbers. Now it's really key that you learn that definition. It's a favourite exam question. Okay, so let's have a look at how we work out relative atomic mass. Guess what? We've got an easy process, only 3 steps. So, first step, multiply each relative isotopic mass by its isotopic abundance. Step 2, add up the results. Step 3, divide by the sum of the abundances. Now, when you've done this, the value that you've calculated is the relative atomic mass of the element. Now, just a quick hint here. If in an exam question you're given abundances as percentages, just divide by 100. So let's make sense of all what we've just talked about by working through an example. A sample of magnesium contains 78.60% magnesium 24, 10.11% of magnesium 25, and 11.29% of magnesium 26. Use this information to calculate the relative atomic mass of magnesium in this sample. And you've got to give your answer to 3 significant figures. So big hint, when you do give your final answer in your calculation, make sure the answer is to 3 significant figures, otherwise you will not be able to pick up the mark that's available for this. Follow the steps. Multiply each relative isotopic mass by its isotopic abundance. So we had 3 isotopes. So here we go. We've got magnesium 24, 25 and 26. So the percentage were given to us in the question. Then we add up the results. Okay, so I've colour coded it so you can see where the numbers come from. And then you divide by the sum of the abundances. Okay, so in this question, the abundances were given as a percentage, so all you do is divide by 100. And the answer that you end up with is 24.3. So that means the relative atomic mass of magnesium is 24.3. A little clue here. So if you look at your periodic table and you look at the relative atomic mass of an element and you see that the number is not a whole number, that's a big telltale that that element has isotopes. Let's have another look at a worked example. So, this time we're looking at copper. Copper has 2 stable isotopes, Cu63 and Cu65. Cu63 has an abundance of 69.2% and Cu65 has an abundance of 30.8%. Calculate the relative atomic mass of copper to one decimal place. Let's do that with our 3 easy steps. So, we take the values given to us in the question and we multiply the relative isotopic mass by its isotopic abundance. Again, the numbers are colour-coded. Then we add up the results. So you can see the red number corresponds to copper 63 and the blue purpley number corresponds to copper 65. Again, in the question, the abundances were given as percentages, so we just divide the number by 100, and voila, we have the relative atomic mass of copper, and we've calculated it to be 63.6. So, we did it, or you did it, and you did it by following the 3 easy steps. So, I hope you found this video useful. If you have, please give it a thumbs up and hit subscribe so you'll be notified when more videos are added. If there are any other calculations in biology, chemistry or physics which make your head hurt, please add them to the comments below and you may see your request very soon.
All things sciencey, we do best. Miss C helps you pass the test. Whee!